بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the final exam of Stat 101 Term 222, and let us have a look to the exam and solve it together. The first part is multiple choice questions. A car salesman noted that the dealership's probability of selling a car on a Saturday is 0.3. Then the probability of the dealership not selling a car on Saturday is what? If the probability of selling a car on a Saturday is 0.3, then the probability of not selling is 1 minus probability of A, where probability of A is 0.3. So it's 1 minus 0.3, and that's 0.7. So answer A is correct. The special rule of multiplication is used only when events A and B are. When we have the multiplication rule, and the multiplication rule says that probability of A intersection B is equal to the probability of A times probability of B given A. Or it is also equal to probability of B times probability of A given B. So this is the multiplication rule. There is a special case of multiplication rule when A and B are independent. When A and B are independent, probability of A given B would be equal to probability of A. So in case of independence, probability of A given B would be probability of A. And probability of B given A would be probability of B. So probability, the product rule in this case, the multiplication rule, will give you probability of A intersection B equals probability of A times probability of B. This is in case of independence, okay? A study was recently conducted to estimate the mean cholesterol for adult males over the age of 55 years. Given that the following random sample data were observed, the point estimate for the population mean. Well, the population mean is denoted by mu, and the point estimate for the population mean is x bar. So mu is the population mean, x bar is the sample mean. Here we have a sample, so all what we need to do is to find the sample mean, the mean of the sample. I urge you to use the calculator, okay? You go to mode 3 or stat, okay? And then you press 1 VAR or variance. And then you put the data, 242 equal 300 equal 133 equal 202 equal 300 equal 210 equal 199 188 256 390. And then you press on or AC, and then you press shift stat or shift 1. There is number 4 variance, okay? You need variance. And there is X bar, number 2 X bar. And if you press equal, it will give you 242. So the mean of the sample is 242, and that's the best point estimate for mu, or the population mean. In a negatively skewed normal distribution, okay, if it is negatively skewed, the graph would be like this. So there are many of the data to the left of the distribution. Here is the mode. And usually the mean affects by these numbers to the left. So the mean becomes closer to the skewness. So this is the mean. The median will remain here in the middle. The median, 50% of the data to the right of the median and 50% to the data to the left of the median. So X bar is always becomes closer to the skewness. So if this is a number line, X bar would be less than MD in this case. So the mean is smaller than the median in this case. In the other case, positively skewed, X bar will go to the right of the median because it will become closer to the skewness and it will be larger than the median in that case. In a population of college students, 25% of students prefer afternoon classes. If a random sample of 100, this is N, students, 100 students, is taken from this population, what is the probability of B hat less than or equal to 0.31? Okay. In a population, 25%. So this is the population proportion, okay? So this is P. P is 0.25. To find probability of B hat, we have to change it to Z. And we change it to Z using the formula. Probability of Z less than or equal 0.31, which is B bar, minus P, which is 0.25, over square root of P, which is 0.25, times 1 minus P, which is 0.75, over N, which is 100. So this is how we change B bar to Z. The formula is Z equals P bar minus P over square root of P times 1 minus P or Q over N. So if you put this in the calculator, 0.31 minus 0.25, you will find that Z is equal to 1.3856. And we need 2 decimals only. So I will take it 1.39 because after 8 I have 5. So 1.39. Now you can use the table of Z to find this probability, or you can use the calculator. I urge you also to use the calculator here. And in the stat mode, if you are in the stat mode, you press shift stat. Number 5 would be distributions. So press 5. You will have number 1 P off, number 2 Q off, number 3 R off. So number 1 will give you this probability of Z less than or equal to 1.39. So press 1 and write 1.39, and the answer would be 0.91774. Always take 4 decimals because the calculator will give you 5 decimals and the tables will give you 4 decimals. So take the first 4 decimals given by the calculator. Which of the following will result in increasing margin of error when constructing the confidence interval of the population mean? Well, what is the margin of error and what is the confidence interval? The confidence interval is X bar, if it is confidence interval for the mean, X bar plus or minus the margin of error. And the margin of error by definition is the critical value times the standard error. And the standard error, in this case, population mean confidence interval for the mean, is defined by sigma over square root of n. So sigma is the population standard deviation and n is the sample size. So what do we need to do? increasing the margin of error? Well, if you want to increase the margin of error, you have to increase the critical value or increase the standard deviation of the population or decrease the sample size because the sample size is in the denominator. So if you decrease the sample size, you will get a larger margin of error. So that's the correct answer. If you decrease the confidence level, what is the confidence level? Well, the confidence level could be 90%, 95%, for example. So if we say that this is 95% confidence level, these numbers would be the critical values. If you decrease the confidence level, bring it here 90%, then the critical values will be also decreased. So critical value will be less. If the critical value is decreased, the margin of error will be decreased. So the only thing with which if you decrease, you increase the margin error is the sample size. Okay. For a standard normal distribution, what is the probability of Z? We just found this probability using the calculator. Be in the stat mode, shift stat, distribution number 5, number 1 P of, write 1.75. The answer is 0.95994. Take the first four decimals. So that would be the answer. The weights in grams of several golden rings are given by these numbers. What is the variance of the weight in this sample? Well, the variance also you can find by the calculator. Brace mode again, stat, number 3 stat mode, number 1 variance, and put the numbers 4 equal 3 equal 5, 7, 4, 5, 6. Using the calculator will help you a lot. Then shift stat or shift 1, number 1 variance. Now he says the variance of the sample of the weights in this sample. So there is Sx and there is sigma x. Sx is the standard deviation in the sample. So if you press number 4, Sx, the answer is 1.34518. This is by the calculator given, 5418. You square it, you raise it to the power 2 because this is the standard deviation and he asking about the variance. So if you square it, you will get 1.809 or 1.81. So the answer is D. The arrival of customers at a service desk follows a Poisson distribution, and they arrive at a rate of 2 every 5 minutes. Rate of 2 means the average is 2, so lambda in the formula is 2 for every 5 minutes. So our segment here is 5 minutes. The probability that no customers means he is asking for probability of 0, x equals to 0. Arrive in a period of 5 minutes, he didn't change the segment, so the number of segments is 1. The formula for the Poisson distribution says probability of x equals lambda t to the power x e to the power negative lambda t over x factorial. Well, here lambda times t is 2, so probability of 0 would be 2 to the power 0 because x is 0, e to the power negative lambda 2, which is 2, over x factorial, which is 0 factorial. 0 factorial is 1, 2 to the power 0 is 1, so the answer is e to the power negative 2. If you put it in the calculator, you will find e to the power negative 2 equals 0.1353. In the second major exam, 3 students scored 8 points. 6 students scored 9 points. 1 student scored 12. The weighted mean. What is the weighted mean of the points the weighted mean of the points scored. So I have 3 students scored 8, plus 6 students scored 9, plus 1 student scored 12. To find the weighted mean of points, I divide by the number of students. If you want the weighted mean of points, you divide by the total number of the other thing, which is students. Well, I have 3 students plus 6 students plus 1 student. So if you use the calculator and divide, you will find that the answer is 90 over 10, which is 9. So that's the weighted mean of the points. Which of the following is true in a standard normal distribution? We know the normal distribution, it has this shape, okay? Well, here, the mode and the median and the mean all here at this point. So they are all equals. The 3 mean, mode, median are equal. The area under the curve, of course, is 1. And the mean divides the distribution into 2 equal parts because the mean is here, is equal to the median. So 50%, 0.5 of the area is here, and 0.5 of the area is here. So in fact, all of the above are correct about the normal distribution. If A and B are mutually exclusive means like this. This is A and this is B. There is no intersection between them. Probability of A intersection B is just 0. A intersection B is phi. There is no intersection between A and B. So we know that the probability of A union B or A or B, there is a formula for the union. It's probability of A plus probability of B minus probability of the intersection. But if the 2 events are mutually exclusive, then the intersection is 0. Intersection is phi. Probability of the intersection is 0. So the probability of the union would be probability of A plus probability of B, and that would be the correct answer. A competency test has scores with a mean of 80 and a standard deviation of 10. So the mean is 80 and standard deviation is 10. Using the empirical rule, the percentage of scores between 70 and 90. Well, the empirical rule, to use the empirical rule, we have to move 1 standard deviation to the right, 1 standard deviation to the left. Standard deviation is 10. So 80 plus 10, 90, 80 minus 10, 70. You can move also another standard deviation until you reach these numbers given in the question. But he says 70 and 90, so there is only 1 standard deviation to the left. So in fact, this is mu plus sigma, and this is mu minus sigma, okay? So this is the first interval. So empirical rule says in the first interval, approximately 68% lies in that interval. In the second interval, 95%. In the third interval, 99.7. So if he asks from 60 to 100, for example, the answer would be 95%. From 50 to 110, the answer would be 99.7%. The binomial and Poisson distribution are used to describe, of course, Poisson and binomial are discrete distributions. They describe discrete variables. Continuous variables are described by the normal distribution. The variance of the binomial distribution. The binomial distribution, the formula for the variance, the variance is sigma squared, and the formula is n times b times q. So n here is 900. P probability of success is 1 over 3. Q is probability of failure, which is 1 minus P. 1 minus 1 over 3 is 2 over 3. If you multiply these 3 numbers by the calculator, you will find that the answer is 200. Now to the other part of questions. If a random sample of 100, so this is n, sample size. is taken from a population in which the proportion of items having a desired attribute is P. So this is P given in the question, which is proportion, population proportion. What is the probability that the proportion of successes in the sample? So he is asking about probability of B hat or P bar is greater than 0.45. So this is similar to one of the multiple choice questions. We need to change it to Z. So it is probability of Z greater than, I wrote the formula above. It is P bar minus P, which is 0.4, over square root of P, which is 0.4, 1 minus P, which is 0.6, over N, which is 100. If you use the calculator to find the value of Z, you will find that the value of Z is 1.02. You take two decimals. And how to find this probability using the calculator? Well, this is a probability of Z greater than. So be in the stat mode, shift stat number 5 distributions, and then number 3 R. R will give you the probability to the right of Z. So write R of 1.02, and the answer by the calculator would be 0.15386. So I will write it 9. I will take the 4 decimals. So it looks like I took it from a table. 0.1539. Given that the population has a mean, so this is the population mean, and the standard deviation, so this is the population standard deviation, compute the coefficient of variation. Well, the definition of coefficient of variation, it is sigma over mu. It is the standard deviation, coefficient of variation. So standard deviation up over mu times 100%. That's the definition of the coefficient of variation. So sigma is 3,000, mu is 21,000 times 100%. If you use the calculator, you will find that the answer is 14.29%. Determine the 95% confidence interval estimate for the population mean. Well, the rule for the 95% confidence interval for the population mean X bar plus or minus Z, the critical value. Well, at 95%, the critical value is 1.96. This is a very famous number, and it would be nice if you just memorize it, or you can find it from the table, times sigma over square root of n. That's the confidence interval. Assume that a random sample of size 64, so this is n, is collected, and the sample mean, so this is X bar, sample mean, 1,300. Also assume that the population standard deviation, so this is sigma, so X bar is 1,300 plus or minus 1.96 times sigma, which is 117 over square root of n, square root of 64, or just 8, because square root of 64 is 8. Well, this number, which is 1, remember, 1.96, this is the critical value, this is the standard error, and this is the margin of error. So in fact, the confidence interval would be X bar plus or minus the standard, the margin of error. And the margin of error, you can find it by the calculator. It's 1.96 times 117 divided by 8. And it's 28.665. And now to find the interval, and I'll say that mu belongs to this interval, I find 1,300 minus 28.665. This would be the lower limit of the interval, and it's 1271.335. And then the upper limit I add, so it would be 1328.665. So this would be the confidence interval of mu. Let x be a random variable that follows the binomial distribution with a probability of success equals to 0.65. So this is p. And 1 minus p, or q, would be in this case 1 minus 0.65, which is 0.35. If the number of trials is equal to 7, this is n. Number of trials is n. Probability of success is p. What is the probability of having at least 6 successes? At least 6 means at least 6, so 6 or more. So he is asking about x greater than or equal to 6, because 6 or more, 6 or 7 or 8 or whatever. Well, what is n? N is 7, so x always run from 0 to n. So probability of x is greater than 7 is probability of 6 plus probability of 7. Well, you can use here the rule twice, or you can write it if you want to find it at once by the calculator. You can write it like this, summation. The rule says NCR, so NCR. What is n? N is 7. Well, here I will write x, okay? Because I want to find the two together. The first one would be 7C6, second one would be 7C7. And x is running from 6 to 7. This is the summation, okay? Times P, probability of success, which is 0.65, raised to the power x, times 1 minus P, which is 0.35, raised to the power n minus x, or 7 minus x. So just put this in the calculator using summation mode. It is above the log. Okay, you need to use shift for that. So write summation 7cx. C is the combination above the division mark. Okay, use shift also. Times, right here times. Okay, 0.65 to the power x, 0.35. You know how to write x. It is also x, use alpha to write the variable x. And you will find that the answer using the calculator. This will help you not to use the tables. You can, the calculator will give you even an answer without using the tables, the binomial tables or the boson tables. The calculator will help you. All right. Compute the median. The following data are shown. Data set shows the marks of 10 students, okay? So to find the median, we need to arrange the data. So the smallest number is 10. Then I have 13. Then I have 2 15s. Then there is 17. Then there is 20, 22, 25, 27, and 30. 2, 4, 6, 8, 10, 10 numbers. Compute the median. Well, the median is in the middle, okay? So if you just 1, 2, 3, 4, 5, 1, 2, 3, 4 here, this is the middle. I have 5 numbers to the right, 5 numbers to the left, okay? So the median is in the middle between 17 and 20. So the median is 17 plus 20 over 2, and that's 18.5. But if you want to use the method in the book, it's also, of course, the index. You find the index of the median. By definition, it is n over 2. So n here is 210 over 2, so the index is 5. The rule says if the index is an integer, number 5. So you count now 1, 2, 3, 4, 5. This is the fifth data, okay? So if it is integer 5, the median would be between 5 and 6. So the median would be between 17 and 20. That's the formula, okay? It says third quartile. Well, the third quartile is here, 0.75 of the data is to the left of the third quartile, and 25% of the data, this is called the Q3. This is the third quartile. So the index of the third quartile, how to find the index? 0.75, you multiply 0.75 times n. And 0.75 times 10 means 7.5. Now this is not an integer, so you take it immediately to number 8. So the Q3 would be number 8. This is 5, 6, 7, 8. So 25 is the third quartile. Well, this is a method using the index, but also there is another method which says that now the median, we said that the median is in the middle. So I have 5 data to the right and 5 data to the left. Q3 is the median of the 5 data to the right. So you see that you have 5 numbers here. Well, in the middle, I have 25. So this is a Q3. And if you want Q1, it is here in the middle, which is 15. This is a Q1 and this is a Q3. You can just do it like this, or you can use the index. You will get the same answer. 80th percentile, we call it P80. And 80th percentile, by definition, 0.8 or 80% of the data are to the right and 0.2 to the left. This is the 80th percentile. We call it P80. So how to find the index? You multiply 0.8 times 10, which is n. So 8. It's an integer, so it would be between 8 and 9. So this is 5, 6, 7, 8, 9. So the 80th percentile would be between 25 and 7. So P80 would be 25 plus 27 over 2, and that's 26. Compute the range. That's easy because the range is the maximum minus the minimum. And the maximum is 30, and the minimum is 10. So the range is 20. The following table shows the discrete probability distribution of the random variable x. Calculate the expected value. Well, the expected value of x by definition is x times px. So summation of x px. So 7 times 0.11, okay, which is 0.77 plus 10 times 0.17, which is 1.7 plus, times 13 plus 13 times 0.22. By the calculator, it is 2.86. 16 times half, that's 8. The sum is 13.33. So that's the expected value of the random variable. The mean number of typing errors per page made by administrative assistant is 2.8. So this is lambda or mu. Per page means it could be a Poisson. Yeah, it's a Poisson distribution. So lambda is 2.8. And the segment here is 1 page per page. The number of errors is distributed according to Poisson distribution. If 1 page is examined, so number of segments is 1. What is the probability that more than 2 errors? So probability that x is greater than 2, more than 2. So 2 is not included, okay, are observed. You know, in a Poisson distribution, the x starts from 0 and continues, okay? It doesn't stop, there is no stopping. So to find probability of x greater than in a Poisson distribution, I have to find 1 minus probability of less than, x less than or equal to 2. because greater than 2 means 3, 4, and continue. So the total probability is 1. So it's 1 minus the numbers that are not here, which is 0, 1, and 2. So you can find this probability either by finding probability of 0, 1, 2, adding them, and then subtract from 1. Or you can use the calculator like this. Or you can use the table, the Poisson table if you like, but I'll use the calculator. It's 1 minus, I write probability summation, okay, as a summation because 3, I need to find 3 probabilities together, x from 0 to 2, because I need to find probability of 0 plus 1 plus 2. Okay, what is the formula of the Poisson distribution? Well, I have lambda t, which is 2.8 to the power, what? Lambda t to the power x. Well, x could be any number from these, so I'll just write it, x, times e to the power negative lambda t, which is 2.8, over x factorial, because x changes. Could be 0, 1, or 2, so you write here x and you write here x, and you put that in the calculator. You put this sigma in the calculator, and you will find that the answer by the calculator is 0.4965. So 1 minus this number would be 0.5305. Or you can use the Poisson distribution tables. You go to mu equals 2.8, and then x equals to 0, x equals to 1, x equals to 2, and you find, you just go to 2. There is x less than or equal to 2, there is a number there. You will find that it is 0.4965. For a standard normal distribution, determine a value z0 such that the following probability is satisfied. Okay, here I have to use the tables to find z0. I do not have the tables here, but I will illustrate the method for you. The table of z given for you is like this. This is 0, and the numbers inside the table are these areas from 0 to a number here to z0. Okay, these are the numbers, these are the areas given in the table you have. So he is asking about z0 such that for a standard normal distribution, determine a value z0 such that the following probability is satisfied. The probability is not given. The probability is not given here. Probability of negative z0. He has to give you this in the question. Z less than z0 equals to some probability, okay? I think it's 0.95, if I'm not mistaken. He has to give you something like this, okay? So if I have something like this, how to answer the question? Well, you sketch the graph. This is 0. This is negative z0. This is z0. And here is the area given, which is 0.95 or 0.96 or whatever. I'll make it 0.96 because I have to divide by 2. This is just an example for you to understand the method. Okay, I need to find this z0. This is the area 0.96. Well, I need this area only, not all of this, because I need to use the table. So I have to divide 0.96 by 2. The answer would be 0.48. So this is 0.48. Okay, good. Now I have to look to 0.48 in the table. If you look inside the table, you have the table of the normal distribution. Look inside the table, search for the area 0.48, and then you will find the value of z0. And please check that this value in this case is 2.06. If you want more exercises about this point, please look to the video about chapter 6.2, I believe, or 6.2. It will give you many examples about it. Suppose the life of a particular brand of calculator battery is approximately normally distributed with a mean of 75. So this is mu. And the standard deviation, this is sigma. What is the probability that a single battery, one battery, selected from the population? So probability of X in this case, because the life of uh, the calculator battery is normal. So X is asking about probability that a single battery have a life between 65 and 85. So what is the probability that X is between 65 and 85? Well, I have to change it to Z. And how to change from X to Z? Well, Z is X minus mu over sigma. So 65 minus 75 over sigma less than X minus mu over sigma is Z. 85 minus 75 over 9. And putting in the calculator and taking the first two decimals, it would be probability of negative 1.11 and 1.11. Well, how to find this probability using the calculator? Well, you have to understand this is 0, and this is 1.11, and this would be negative 1.11. Well, I can find this area by the calculator or by the table. And then this area is equal to it. So in fact, this is 2 times probability of Z between 0 and 1.11. So it is 2 times. Well, probability of Z between 0 and 1.11, you can find it from the calculator also. I told you in the stat mode, shift stats, number 5 distributions, P, number 1 will give you probability less than 3R will give you probability to the right. Number 2, Q, will give you probability between 0 and the number. So write Q 1.11. The answer would be 0.3665 multiplied by 2, and you will have the answer 0.733. So this is the required probability. The population mean for a random variable is 130. The following table shows random sample measurements of 8 items from the population. What is the sampling error of the sample? Well, the definition of the sampling error in section 7.1 is X bar minus mu. That's the definition of the sample error. So I have mu 130. To find X bar, I will use the calculator to find the mean of these 8 numbers. So I'll go to mode stats 3 and then number 1 variance and write these numbers 140 equal 150 and so on. Put all the 8 numbers 145, 149, 142, 154, 124, and then press on and then shift stats, go to 4 variance, ask for 2 X bar, and X bar is 1.39.375. Subtract from the mean, the population mean, the answer is 9.375. So that's the sampling error for the sample. Suppose that a population is known to be normally distributed with mu and sigma. If a random sample of size 81 is selected, calculate the probability that the sample mean X bar will exceed 2,400. So we need the probability that X bar is exceeding or greater than 2,400. Well, how to change X bar to Z? The formula says Z equals X bar minus mu over sigma over square root of N. This is mu of X bar, mu, and this is sigma of X bar, sigma over square root of N. So change to Z, 2,400 minus mu, which is 2,300, over sigma, which is 250, over square root of 81, which is 9. And using the calculator, this would be probability of Z greater than 3.6. Go to the calculator, stat mode, number 5, distributions, number 2 R, you find R of 3.6, you will find that the answer is 0.002. The answer in the calculator may appear as like this, number 3.6. You will find that the answer is 1.5915 times 10 to the power negative 4. We'll press shift eng twice. Shift eng. Eng, E-N-G, okay? It is in the last row before the numbers. You will find that the answer is 0.00015915. So take 4 decimals. So after 1, there is 5, so write it 2. So this would be your answer. Suppose a quality manager for a computer manufacturer inspected a total of 600 disk drives, and the result of the inspection is shown in the table below. What is the probability of randomly selecting disk drive from the company C? Okay, we need the probability of selecting a disk drive from the company C. Well, this is the company C. The disks in the company C are 55 plus 5 over the total number of disks. So it is 60 over 600. So it is 0.1. That's the probability. What is the probability of receiving a defective disk? Okay, choosing one disk and probability of defective. These are all the defective disks. So you need to add all the defective disks, 10 plus 5 plus 5 plus 20, and divide by the total number of disks, and the answer would be 1 over 50. Okay. 40 over 600 or 1 over 50. What is the probability of randomly selecting a defective disk? Let us call it D. I think, yeah, okay. Given that this is a conditional probability, it was supplied by company C. So he needs the probability of defective given C. Well, by definition, it is the probability of defective intersection C over probability of C. Or you can just divide the numbers of defective in C, defective and C. So defective and C, this is the number 5. This is defective and C, so 5 over total number of C drives, which is 55 plus 5. This is all the total in C. So 5 over 60 or 1 over 12 will give you the answer. If you want to use probabilities, you can write it 5 divided by 600 over 60 divided by 600, and you will get the same answer. This was the last question in this exam. Hopefully you enjoyed listening to the solution of the exam. Thank you very much, and see you in another video.